Anybody have any just general questions here before I start the last topic of the unit? It's been a long one, huh? I don't even know the date you started this, but remember the good old days with classifying triangles, isosceles, acute, obtuse, good old days? Who knew you were going to get this deep in the triangles? All right, last day here. I want to take a middle school concept and apply it to congruent triangles for this unit. You guys remember doing transformations back in middle school? Oh, those were fun, right? Sliding, flipping, turning. That was so fun. All right, I want to now apply that to what we're doing right now, which is congruent triangles. One more new vocabulary term today. You guys have it on your notes. I don't have it up here. What's called a rigid motion. A rigid motion. Basically, here's a rigid motion. I move a figure, I change its position, I move it, so I slide it, I turn it, I flip it, and the original is congruent to the image. Okay, the two triangles I'm left over with are still congruent. So there's three types of rigid motions you're probably familiar with. Three types. First one's called a flip. We don't call it a flip anymore in high school honors level geometry. We call it a reflection. So I want everyone in their mind right now, take a triangle, flip it. Is it still congruent to the original one you started with? Yeah, that's why it's considered a rigid motion, because it doesn't change its size or shape. Next one, a slide. Slide. We call that in big boy, big girl geometry, translation. So everyone think about a triangle right now. I'll even draw one up here myself and do it. Ready? Up, down, left, right. Actually, you know what? Watch this fancy stuff. I'll even duplicate. Oh, up, down, left, right, diagonal. If I slide it all around, are the two still congruent? Doesn't change. That's a rigid motion, a translation. And the final one, what about a rotation? If I turn a figure, is it still the same size and shape? Yeah, it's still the same size and shape. Those two are still congruent. So these three up here, reflection, translation, rotation, we refer to as a rigid motion because it does not change the size or shape. I think I'm missing one from your middle school days, aren't I? You talked about 4 back in the day. Yeah, I'm pretty sure you did.
Wasn't there dilation?
Oh, yeah. Everyone remember that one? Dilation, no? Don't remember that one? Why don't I have it up there? Why don't I have dilation up there? Just leaving it out on purpose? Nope. Why, Kyla?
Is dilation where the triangle gets bigger or smaller?
That is when the figure gets bigger or smaller. So in that case, would they be congruent? No. So that's why you don't see dilation as a rigid motion, because it changes the size and shape. Or it doesn't change the shape, it changes the size. All right, so these are my 3 main ones we're going to focus on today. Reflection, translation, rotation. Types of rigid motions. Okay, real basic right now, real basic. What did I do here? Did I reflect, translate, or rotate to get to one figure to the next? Pretty basic, just make sure we're good. Here we go, first one. What's it look like I did? I have no idea. Somebody want to chime in? Nope. Okay, Lucas, here we go. What did I do for the first one? What's that?
Reflection.
That's a reflection, yep. That's a reflection. Again, as you guys can see, they're still congruent to each other. I did not change the size or the shape. That's why I consider a reflection a rigid motion. It does not change the size or shape. How about the second one? What's it look like I'm doing there? Quincy, what's it look like I'm doing?
Rotating.
Rotating, yes, rotation. Everyone's all good? No big deal. And then how about the final one there, 1C? What's it look like I'm doing there? You can see they're still congruent to each other. Oh, 8, here we go. Ryan, what's it look like I'm doing on that one? Last one.
A translation.
That's a translation, aka a slide back in the middle school days. A translation. All right, no big deal. Perfect. Here's what I want to get to is the honors level. Now I want to put these triangles on a graph. I want number 1, after we graph them, what did I do? Reflect, rotate, translate. And then prove to me that I actually did a rigid motion. Okay, prove that we actually did a rigid motion. So I'll let you guys graph it. And then I'll ask somebody what transformation just happened. And then as a big group, we're going to figure out if we actually did a rigid motion here. And I'm going to change it up here today too a little bit. Hopefully you guys enjoy the little interactive session we're going to have with each other. Okay, first question. What transformation is happening? That's the first thing we need to get through. What's it look like? What transformation was performed? Here we go. Not here today. Moving on. 14. Ellie, what's it look like we just did?
A reflection.
Good job, Ellie. Reflection. Good job. Reflections. All right, now here's where we're going to put in a little work, kids. Prove to me that it actually is a rigid motion that we just performed from ABC to XYZ. How can I prove that to you? Well, if a rigid motion actually happened, I know these two figures have to be congruent to each other. So let's back up a couple days. On a graph, how do I show two triangles are congruent? I was just going to say we had 5 methods, right? Going too fast. But only one can happen on a graph. There's pretty much no way I could show angles are equal on a graph. So anything that involves an angle is out. HL, you need right triangles. Okay, well, I probably could show a right angle, but easiest way, side, side, side. Show all 3 pairs of sides are equal by using what? How can I find the lengths of all 3 sides so I can compare them? Distance formula. I'm not going to make this painful on you and find all 6. You guys in class, which triangle do you want? ABC. All right, you guys in class, you're going to find the lengths of all 3 sides of triangle ABC. You guys at home, you're going to find all 3 lengths of triangle XYZ.
Can you use Pythagorean theorem too?
Or Pythagorean theorem works as well, whatever floats your boat. Reminder, I'll write the distance formula up here just as a little reminder. We got big square root underneath x2 minus x1 all squared plus y2 minus y1 all squared. And if possible, you know how you're going to leave your radicals, don't we, kids? Honors kids, how are we going to leave our radicals? If possible. Simplest radical form, if possible, break those suckers down. So again, you guys in class, you're responsible for the side lengths of triangle ABC. You guys at home are responsible for the side lengths of triangle XYZ. And hopefully we got some matches. If not, this thing's not a rigid motion. Again, if you could break it down for me, that'd be great. Have a good one. We ready to roll? Okay, we've been doing way too much math here, so let's spice this up a little bit. If you get called on, first thing you tell me, if you could eat one food for the rest of your life, what would it be? Get to know a little bit about each other now, and then you can give me whatever side you want to give me in radical form. All right, so first question, one food for the rest of your life, what would it be? And then you can tell me whatever side length you want here. All right, let's get this party started. Let's start it off. Hayden, here we go, Hayden.
Cheese.
Okay, can I ask what kind?
Cheddar.
Just cheddar, that's it.
Mm-hmm.
For the rest, just cheddar cheese, and that's it.
Yeah.
That's not going to get old pretty quickly, or?
No.
Okay.
I mean, like, typically it might expire, but I'll just buy more cheese.
Okay. Hey, it's your question. So cheddar cheese for Hayden. Cheddar cheese. All right, triangle XYZ, Hayden, which side you're going to give me?
YX.
Okay, YX, what'd you end up? Ooh, going the big one first. Go ahead, YX, what'd you get?
2 radical 10.
Good. Some of you guys probably got square root of 40. Square root of 40, which can be broken down into 4, which is the perfect square, and 10, and that's where Hayden got 2 square root of 10. Good job, Hayden. Good job. Everyone all right? Let me know. Hey, if you guys didn't get that, please let me know right away so I can show you the math behind it. All right, because I'm just showing what's underneath the radical. I don't show you what I subtracted, what I squared, just the number underneath the radical. All right? We didn't get that one?
I didn't.
Okay. So XY, here we go. XY. What are your numbers underneath? What 2 numbers? Let's start with the numbers you subtracted for X and Y.
Oh, that one? I already had the other 2 sides, so I punched it into the Pythagorean theorem.
Whoa. Pythag only works for what type of triangle?
Oh, is that only right triangles?
Only right triangles. That doesn't work for every triangle. So if this is not a right triangle, yeah, you're not going to get 2 radical 10.
That would make sense.
Okay? Anybody else? Good question. All right, here we go. Let's keep this train going. 22. Hannah. Here we go, Hannah.
French fries.
Oh, nice. Straight cut, curly, steak French fries.
Straight cut.
Just straight cut? Okay. Crispy or not?
Yeah.
Plain, or do you throw some ketchup on that? What do you have?
Sweet and sour sauce.
Ooh. Okay. I feel you. All right, not bad. Not bad. All right, what do you got, Hannah? Which one? You want YZ or XZ?
I'll do XZ, I guess.
Sure, go ahead. What do you got for the length of XZ in radical form?
Radical 17.
Great job. Radical 17 is what I have as well. You cannot break down 17 at all. No perfect square goes in. Good job, Hannah. Here we go, guys. Let's keep this going. 13. Here we go. Sophia.
I could go with the boring option and just say sandwiches because there's a big variety, but if I had to pick something specific, it'd be chicken pot pie.
Okay. Okay, nice. What is in your?
Just need one to be done for the day.
What is in your chicken pot pie?
I mean, probably just the standard, like peas, carrots, chicken, sauce.
Got it. Okay.
My only pet peeve is that it cannot be like a gravy consistency sauce. It has to be creamy. If that was the case, then I'd be good for probably for the rest of my life.
Now, would this be like a mini pie or a like regulation size pie, like an apple pie or a blueberry pie type size? What do we talk? Because you got to get through a day. I don't know what your preference is.
I mean, it depends on whether I'm having a snack or if I'm gonna have a full dinner. Probably a regulation is easier, and then I can just heat up the rest.
Okay, got it. Nice. All right. What about the crust? Flaky? It's important.
Yeah, that's be like a fine line between probably like somewhat flaky, but it shouldn't be like too thin.
Yep. Should be kind of sturdy, right? You don't want it to fall apart. You stick the fork in and everything just collapses, right?
Yeah.
These are important questions, everyone. Important. All right, what'd you get for YZ?
I got square root of 29.
Yeah, you did. Good job. Square root of 29. So hopefully you guys in class are looking at these and you're like, okay, hopefully we're starting to match up a little bit maybe. Because hopefully these are going to be congruent. If not, we got to find out why. All right, you guys at home, make sure you have triangle ABC written down as well as your classmates give me their answers. All right, let's see. Does the generator know that it's got to be somebody from here? Nope. There we go. Oh, Maeve. Here we go, Maeve. I don't care what you got for AB.
I'm sorry. Watermelon.
Watermelon.
Or bacon.
The question was one food.
Okay, watermelon.
Really?
Yeah.
Seedless or seeds?
Seeds.
Seeds? Okay, so you gotta spit them out.
Not the black ones, like you get the white ones.
So seedless.
Well, they have seeds in them.
But the black one, never mind. Jeez. Okay, wow, that's interesting. I really don't have much questions because there's not much detail to watermelon, right? Would you spoon it out or would you cut it like, the usual?
I don't like that because it like gets your face wet and sticky.
You're going to be eating for the rest of your life. I don't think that's really a concern if it's going to get
It
you
has to be like
dirty or not.
It has to just pop it in your mouth.
So you put it in like little squares?
Yes.
Okay, yes.
Okay.
I like this.
Do you do the shape? Oh, so you do shapes. You cut, so you could basically cut it off the rind and you put this part into shapes.
I don't cut it into the thing. I just cut it in half and I cut it again and I cut that and then I do the square.
With the rind still on it.
No.
So you cut it off.
I cut the rind off.
Yes.
And I
Okay.
do-
Shapes like cubes.
Yeah.
I got you. Okay.
And they have to be symmetrical.
Okay. Hey, that's important. It's got to be symmetrical, guys at home. Watermelon's got to be symmetrical. All right. What do you got for me, babe?
I got for AB I got 7.
AB, radical 17. Good job. Radical 17. Nice. All right. Watermelon can only go up from here. Luke!
Bacon.
Bacon.
You just stole my second one.
That's a long life just to eat the bacon.
And you probably live a short life, but.
Turkey, meat,
Meat.
bacon. How crispy?
Very.
Very crispy? All right. Let's see. I don't think I have anything else to
Would you
say.
rather have it like burnt or like really flappy, like not cooked at all?
Hence crispy, Maeve.
I know, but like,
How can it be flappy if it's crispy?
well, it's not always gonna be crispy. Is the food magically?
If it's crispy, that thing ain't moving.
You could also just like put it on the
Just
stove.
a general bacon question.
You can just cook it.
Well,
Wait, since when does bacon move?
It's true.
I'm lost here.
when
When
you
it's still
touch it.
alive.
All right. Bacon
I
it
think
in.
with the help of a person, like if you waved it around.
Are we done?
Like a fly.
Guy just wants some bacon. Leave him alone. All right. Just want some bacon. All right. What do you got for me, Luke?
BC is radical 29.
BC radical 29. Got it. Yep. All right. So we have side. One more person for AC. Kyla.
I'd probably eat some sort of crepe.
Okay. Anything in it?
Well, yeah, but I don't really know.
Okay. I'm not too familiar with crepes, but
Oh, I really like eating Nutella crepes. You could put bananas in it. You can still eat it with like syrup.
is it cooked? Like you just gotta. I'm not too
It's
familiar.
Like a
a
thin
little
pancake.
pancake.
Okay.
Except you put
Like a thin pan, like a burrito
it's like a
type
burrito
Yeah.
except for breakfast.
with bananas in it.
Yeah.
and chocolate.
So are the bananas warm because you're cooking it?
You wanna cook it with the bananas in it? You
So-
cook the little pancake.
You cook the crepe is just the dough that's cooked, like the thin
It's like a
sheet.
pancake.
It's like a little pancake.
And-
like a
So you cook the shell and then you put in the fillings afterwards.
Yeah.
Got it. Okay.
And then, for a side AC, I got 2 Radical 10.
2 Radical 10. Good. All right. Now that we know some foods we'd eat for the rest of our lives, we also know that this is a rigid motion because these 2 triangles are congruent by. So triangle ABC, congruent to, now be careful here, I'm going to ask somebody. Triangle ABC is not congruent to triangle XYZ. They do not match up. Just because it follows in the alphabet, it does not match up. I am sorry to say. Okay, because AB does not match up with XY as far as the distances go. So I need somebody to tell me the correct order there because it's not XYZ. Triangle ABC congruent to Sinjin.
XZY.
Nope, not the answer I was looking for.
Can I get a hint?
Yeah, your favorite food.
Oh, the favorite food for
Yeah, let's go here. Let's go. There's been a pattern here. The last 6 people I've called.
Wait, could I just choose any food and then technically a food could be a drink? So technically, could I just have an infinite amount of
Just follow the rules and pick a food.
Anything could be a drink if you have imagination in a blender.
Okay, I'll just choose French fries and go with it.
Okay, thank you. And what's ABC congruent to?
XZY.
XZY. Let's see, AB, yep, XZ, we're good. By, side. Whew, that was fun, huh? I should have just stuck to what elementary school you went to. A little simpler. All right, that's all I got. I know there was another one, but there's no reason to keep on doing this, and we're gonna run out of time. You have 4 problems tonight. Give me a break. 4 problems. Let's get it done, guys. Good job today. We'll review for the test tomorrow.